Hi everyone, this is Chad. Thank you for joining me. So today I want to talk about the buffer components of this sample, and in particular for when we were doing our resin selection method for ion exchange, right? We were doing anion exchange, but it could be any ion exchange. In this situation, we had the sample components matched the running buffer, which is necessary because if you have too much salt, it'll just go, the sample protein will just go straight through the ion exchange column. This requires dialysis, right, which I did in order to set that up. I didn't really discuss it. I didn't discuss it at all, I don't think. And that dialysis takes time and loads of buffer. You could imagine a situation though where we have a sample and that sample, the solution, does not match the running buffer. We could do this by adding a 5 mil desalting column onto the system. This would limit us a little bit because we could only load about 2.5 mils onto these little 5 mil desalting columns, but we could really test these different ion exchange columns very quickly, right? We could take it directly off of whatever partial purification we're doing right here. In order to do that though, because just review really fast, what's going on is we're going to take this sample, we're going to run it through the Avant, it's going to go through the desalting column, and then we have to hide it somewhere while we wait for the wave of salt on the desalting column to go through the system. And the place we can hide it is on the super loop, right? After it's on the super loop, and the salt wave on the desalting column goes through, we can take it and put it onto the ion exchange column and then into the fraction collector. So you could imagine a situation though now that gets even more powerful and where we can really use this in system, and that's where the sample has a different buffer, but we aren't just running it on one running buffer or one elution buffer. We're doing two different running buffers and two different elution buffers. You could even imagine a situation where we do 5 different running buffers and 5 different elution buffers, but let's just work with these 2 for right now, these 4 buffers right now. So these are the buffers like I imagine in this particular situation that we're going to set up for, and this is what we're going to discuss. And then we would have these 8 different runs overall. So this is going to take a little bit, but we're going to start with the ion exchange method that we used last time. So grab some popcorn. All right, so we're not going to start with a new method. We're going to use the ion exchange selection, like resin selection method that we used before. I think it would be totally bananas to start with a new method. Another couple things I want to say is that I will, run this method, and then we'll do this method together, put together all the, scouting and start protocol information, and then after that, I will test it myself on my own system and make sure it works. If it doesn't, I will come back with corrections, then show you what those corrections are, and then further, I will also post the final method that works in the comment section below, so you can go through those and print it out and type it into your own system and have everything the way you need it. No copyright or anything like that on my part. Okay, so the first thing we're going to do is choose a column to use, and we're going to stick with this HiTrap Q FF column. And the reason is because we need to run a desalting column, which I normally run at 5 mils a minute, but the maximum flow rate for the HiTrap Q column is 4 mils a minute. Let me show you what I mean. HiTrap Q fast flow. So I'm here in column handling, right? I press this button and I scroll all the way down until I found the HiTrap Q column. And you can see here the maximum flow rate for this column is 4 mils a minute. That's pretty close to 5 mils a minute, so we'll just stick with that. Plus a 1 mil HiTrap column is a 1 mil CV, so that makes things pretty convenient. The calculus can get kind of funky after a while. All right, so the next thing we're going to do is change the name of the flow rate here that we're using for the system. We're going to change it to rename. So do I want to keep these two blocks the same name? I'm going to go with yes for right now. That will keep them synchronized, right? And so then I'm going to here, I'm going to change the flow rate to 4 mils a minute. All right, so for right now, the other thing I'm going to do is I'm going to get rid of the gradient view down here so we can see a little bit more of what's going on here. I hope you haven't lost your perspective, like what we're looking at here. So next I want to do is we have to assume that in this method where we've done already a couple runs before, right? And so what would be some of the problems that we would encounter having that? Well, if we've changed the buffer once before, like in the previous run, right, and we're changing it to something new now, we want to make sure that we can flush the system out completely. If we have the injection loop, right, like if we only fill it up part of the way, like let's say we only fill the injection loop up with like 6 mils, right, and then we flush out the entire thing, well, we're going to have 4 mils of the old buffer sitting in that injection loop, right? So we want to flush out the entire injection loop with the new buffer completely. So we're going to change this right here. We're going to add, first we're going to add a flow path instruction for to put the injection loop into the flow path. Insert. And then we're going to actually flush the system with 20 mils because we're going to have a 10 mil loop on here. You could use the super loop in this case, like the 10 mil super loop, or you could use just 2 of those beige 5 mil loops, like, you know, put end to end together, right? Okay, so that's the system's flush phase. Now we're going to do column equilibration, but instead I'm going to rename this. I'm going to rename it Desalting column equilibration, and also here I'm going to rename this the sample load phase. I'm going to call it the Desalting sample load phase. We're going to start splitting things up between the column wash phase and the gradient elution phase. This is where we're going to start putting in the ion exchange method right here, right? So I am going to copy this column wash. I'm going to put another one right there. So we have 2 of them. I'm going to rename this one, and it's going to be Desalting column wash. And then this is going to be the ion exchange. Right. Then the ion exchange elution. So that's when we do the gradient elution, right? Okay. So now we did the column wash. We need the IEX. We need an IEX like sample load. And it's going to be completely different than the desalting sample load. With the desalting sample load, we're going to be using the sample pump. With IEX, we're just going to be injecting using the loop. So it's going to be a very simple loading phase. So I am just going to go to View and Phase Library. In this case, I'm just going to put my own user-defined method in here, and I'm going to call this one. Normally I'm very like OCD about naming these things. Like equilibration there has a lowercase e, and so like half the time I'm not even sure I spell equilibration right. But honestly, like recording these videos, like I don't really care. That's all small potatoes. What's important is that we get the like the overall flow of the method right. You know, sometimes the L might not be like uppercase like it should be. That stuff matters to me, but like I'm really just trying to stay focused here. All right, so we might have to add some more phases later, but you know, since we started talking about what phases we're going to be using, I thought like we would just kind of dive right into it, figure out what we need to do. Okay, so we're running 4 mils a minute, the injection valve. Okay, so the next thing we're going to do is after we've like flushed the system, right? We're going to close the sample valve, the injection valve, sorry. So you're going to go here to flow path and just put it back on manual load, insert. Okay, gradient 0. I don't know why we would do a higher percentage gradient. Sometimes it's just helpful to know what's there. Okay, so then we're going to turn the column position to position 1, and that's not where the gradient valve is. I mean, the desalting valve is, right? So we're going to put it on position 5. That's where we have the column. And then we're going to rename this, and it's going to be, okay, change column position 5, desalting column position. All right, so then we're going to equilibrate the desalting column, and I think I want to, the base is CVs right now, right? Desalting, base. So what I'm going to do though is I'm going to change the column here to, I'm going to do CVs, right? So we're not doing SameAsMain, we're doing CVs, but we're not doing the same HiTrap Q column up here. So we're going to do the HiTrap desalting column. This is where I was saying. I can't remember if it was here my first try, but I said it was going to get a little screwy with the columns. Whoops. I just said desalting. I want desalting. I guess do they make a 1 mil? I guess they don't make a 1 mil desalting column. So change. I'm going to hit cancel because I don't want to change my flow rate from 4 mils a minute to 1 mil a minute. I want to keep my flow rate at 4 mils a minute. And so you'll see that my flow rate right here is still 4 mils a minute. Okay, so I want to double check that right here, the HiTrap desalting column. Oh, yep, see it's 5 mils. Okay, good. I thought I was going to have to go through the column handling, but it tells me right there for me. Okay, so I changed this to 10. I'll be fine with 5 CVs here. That'll be fine. I thought it was going to be 10 mils, so okay. So 5 CVs there. Column position 5. Let me check my notes. Okay, so now we're going to load the sample. I'm going to close these. Sometimes it helps to have like lots of faces open. Other times it just kind of gets in the way. You start losing it. Okay, so the system flow, I want to change that to 0, right? Because we're loading through the sample pump, and we have a low volume setup, right? And we want to run the system through a 5 CV column. Okay, so sample is coming off of S1. All right, the system flow, sample flow is going to be 4 mils a minute, and we're going to do desalting. Loading flow rate. Okay. Change. Okay, injection mark. Okay, so we're gonna get rid of the peak fractionation parameters, right? Because the idea is we want to collect into the fraction loop, right? Delete. Okay, so hold until air sensor equals air 10 mils a minute. Yep, for 10 mils. Okay, so in this case, we're going to do 2.5 mils. I've run desalting columns a lot before, and I know 2.5 mils on these little 5 mil columns is about the best I can do. Yeah. All right, so I'm going to change this to desalting. Right. Okay. Change. All right. You know, this is something we're going to want to test. I have the luxury of being able to use a higher concentration sample when it comes to loading. So, you know, last time when we did the ion exchange resin selection, we did a 5 mil load. Yeah, I'll start with a higher concentration sample, and it'll be diluted as it goes through the desalting column. And as we load it back onto the ion exchange columns, hopefully the volume will be about 5 mils, and the concentration will be about 1 mg per mil, which is, you know, almost the same conditions that we had when we did all of the resin selection stuff. That is loading the sample. So now we're going to introduce a new phase. So I did miss a phase. I'm going to go to View Phase Library, and I'm going to go to, there's no column wash, so I'll just delete this. Probably just could have renamed it, but whatever. Okay, so I'm going to rename this Desalting Elution. Sorry, gotta do it. Alright, there we go. Okay, so for the desalting elution, this is where we want to start collecting our sample. So I am going to go to Watch UV, Watch, and I want UV, and I want it, the test is greater than, right? And the value is going to be 100 milliabsorbance units. And then the action, I can select an action here, right? Like end block, hold, pause, or I can select a block that I already named. So one of those blocks I already named is desalting flow rate, but I can also just type one in. So it's going to be start frac, start, right, insert. So start collection, and I'm going to turn this into a variable. Change. All right, I'm going to open this up, and here I'm going to make this a flow path instruction, and this is where we're going to start collecting it in the injection valve. So I have the injection valve out 1 set like plumbed from the outlet valve to the valve where the syringe goes normally. Insert, right? The next thing I'm going to do is I'm going to put another watch instruction, and it's going to be UV, and it's going to be less than, right? And make this 100. Okay, so UV, the test is less than, the value is 100 milliabsorbance units, so less than 100 milliabsorbance units. And this is going to be stop. Insert, and then I'm going to make this a variable. Change. All right, and inside of here, I am going to put, inside of here, I'm going to put a flow path instruction for the outlet valve. And the outlet valve is just going to go to waste when this is done, right? Okay. And so when that's done, it's going to go all the way back to the elution. Let's see. I feel like there's something missing. Yeah, okay. So first thing I'm going to do is I'm going to change this base, right? I'm going to change it to column volumes, and we're going to do the desalting column again. again, this is asking me if I want to change the flow rate from 4 mils a minute to 1 mil a minute. I'm going to hit cancel, so it'll stay the same. It'll stay at 4 mils a minute. And then, all right, so I'm noticing the name of this block is kind of silly. Is start collection, start desalting frac. I guess that's okay. All right. Then the next thing is that your time is a factor here. I think I'm gonna put a delay block right here because I like delay blocks. You may think I'm crazy, and I am, like, for liking delay blocks so much. And the reason I'm putting a delay block in here is sometimes I've noticed as the valve switches, sometimes the UV can kind of, you know, go back and forth a little bit, and you'll actually go below the stop collection threshold. So I don't want that. Okay, so I'm going to change the time, the base to time, and I still want this to be 1 mil a minute, so cancel. And then I am going to do this just for 3 seconds. Again, metric time, right? Okay, so that'll give a chance for the UV to start climbing. Okay, another thing I want to do is I want to make sure that there's an auto 0 before we start loading, right? I think I could do, no. I was just wondering if I want to put an auto 0 after this. I don't think I'm going to do that. Okay, so that's the desalting elution. Let me check my notes to make sure everything came out. This turned on just for desalting elution, right? I have the column here. So now I'm going to, let me close this. All right, so I want to make sure this phase has long enough for the desalting to actually occur. So normally it's done inside of, like, desalting only takes like 1 phase for the sample to come through, but like the salt can take a couple CVs. So I'm just gonna do 5 CVs, I think. Change. Okay, and then I'm gonna do change. All right. Okay, I think we're doing pretty good. Okay, so now we've collected everything into the loop, right? And did we close the loop? No, not waste. Okay, so this is what's trippy to me, is that we're just running everything through out 1, right? Through the outlet valve, but it's not actually going, like, it's still going into the sample loop. But you don't actually see the injection valve mentioned anywhere in here. So that's just what I think is crazy. If we wanted to, like, we could put like some innocuous comment in here. And so you can put comments in here by other, and then you can go to comment, and you could say sample loop. Sample loop injection, right? Insert. Like, this might be kind of like this, putting in a comment doesn't actually do anything. Like, the system just ignores it. You know, like, if you're writing a method, like, it just helps you kind of see what's there. We'll leave it, I think. And then we'll put another comment in here, which is that comment would be sample loop closed. It's not really closed, which is like kind of why I'm struggling with putting this here. And it's not really a sample loop injection. It's, let's say it's sample loop load. That's better. Replace. Okay, so we'll leave these here. I think, like, you know, since this is an instructional video, having something like this can kind of help someone sort of digest what we're looking at. Yeah. All right. You don't, like, purely comments, purely optional, right? Okay, so sample loading for ion exchange. I think what we need next is, before we go to sample loading, I would like to have another phase in between these. It's sort of like an intermediate phase. So put it right here. And we're going to do IEX equilibration. All right, and so what we're going to do is we're going to turn off some stuff. So we're going to turn the watch off, insert, and then we're also going to turn off the injection valve position. And what I'm going to do is I'm going to change it to position 1. And then this is going to be the ion exchange column. Okay. And so this is the column that we're going to mention as we do the each of the scouting runs. It's going to be important since we we're going to have to change both the column position, right, and the column name right here. We need to make sure we get both of those done. So column position 1, change. Remember, I said I didn't want to just, like, I thought I was going to do 2 column positions. One where I just closed it, another where I opened it, and I just decided that would be silly. All right. Then we need to do a flow rate as well. So we're going to want to do that before the column position. So I'm going to do a block. Insert, and I want this above the column position, so but below the UV. Come on, one more time. There we go. All right, and then this is going to be pumps and flow path, system flow, 1 mil a minute, and it's going to be change. Oh, whoops. I thought I inserted it. Did I insert it somewhere else by accident? Nope, I guess I just never inserted it. That's fun. I can't tell you how much that happens to me. Insert 1 mil a minute. Change. Okay. So then it might be important to put a delay block right here. I'm going to close this desalting elution phase right here so that we can bring the flow rate down, because the PID parameters might not reduce the flow rate fast enough. So I am going to insert a block right here, delay B. And since we're going from 4 mils to 1 mil, like you know what? No, we don't need a delay there, because 4 mils is still within the maximum operating, but it might not. Okay, I'm gonna go with the block there, because 4 mils a minute is within the operating, flow rate for the column, but not necessarily for the the back pressure it's going to create. So I think it's probably going to be a smart idea to put a delay block in here. So sometimes I change my mind. I don't have a delay block in my notes. It's because I haven't run it yet. Insert, and I want this delay block after the flow rate, but before the column position. So that should do it. Yep, okay. And then this is going to be time as well. Time change. Okay, so this is asking me again about the desalting flow rate, right? And the value, it wants to change 4 mils a minute to 1 mil a minute. I still want to keep the desalting flow rate at 4 mils a minute. So I'm going to hit cancel, and it'll keep those at 4 mils a minute. So let me show you. Say still 4 mils a minute. Okay, no problem. Okay, so delayed B, time any. All right, but we haven't, I bet 6 seconds will be enough. Oh, no, and block, that's what I want. 0.1, change. Okay, delog, delay B. Okay, position 1. All right, so now we're going to do ion exchange sample loading, right? This is an empty block phase, empty phase. Okay, so if you remember what the resin selection method looked like, right? We used peak fractionation as soon as we started sample loading so we could collect the flow through as well as the elution. So we're going to do that right here too. So fraction collection. We're going to add the peak fractionation parameters first, and we're going to do level. We're going to start fractionation at, let's do 75 milliabsorbance units, right? Okay. We're doing level for the mode. The end fractionation, same thing. What did I call it? Start fraction threshold, okay. Okay, so. And we want to do this, we'll do this at 75 as well. 75.0, okay. Insert. And then we're going to do peak fractionation, 96 well plate, 2 mil volume. Insert. So now I have the start frac threshold. I think I'm going to change this to start IEX frac threshold. Okay, and same thing with this. And X frac threshold. Okay, change IX. Okay, they're all there. 96 deep well plate. Okay, so now I actually have to do the injection. So now that I've got like those two things lined up, I'm gonna add the injection valve and I'm gonna set it to inject. Insert. All right, and so now all I have to do is, this is going to be, right now this says base SameAsMain, but I'm going to change this to volume. And so this is going to be the volume of the loop that I want to empty. So change, I'm going to hit cancel here. Then I'm going to change the volume to 10. Okay, so we've actually loaded the sample there. Okay, so the next thing I'm going to do is in column wash. This is, it's not empty, which is great, but I am going to add a flow path instruction for the injection valve. I'm going to set it to manual load. Insert, and that changes this instruction back right there. Okay, so now I guess we'll leave the length of wash. It's kind of weird that it set length of wash 1. I think the system automatically did that. So we will get rid of the length of wash. Length of IEX column wash. How about that? That's better. Change, easier to read, right? Okay. So gradient elution. We're not changing anything about this. I think I want to put because like I only have a couple auto zeros, so I think I want to like put another auto zero right here. Monitors, there we go. Insert. Okay. So we're going to auto zero, and then we're going to start the gradient. So target elution concentration. Length of elution. I guess I could just add length of IEX. Okay. Target. I mean, you wouldn't with desalting. Like, there's no way I could confuse this with desalting. But I think it would help to just put jam IX in there a couple times to make sure that it's absolutely clear. After the gradient is done, right now it's 7.5 CVs. I go to 10, that's only a difference of 2.5 CVs. So I think I want to make this 12.5 right here. And that will give me, so just real quick, change. So what that does is that'll give me a 5 CV difference. So if I change this right here to 10 CVs, it should say 15 there, just to double check. Yep, okay, good. Can never overcheck this stuff enough, in my opinion. Change, okay, so we're back to 7.5, nothing's really changed there. Okay, I think that's it for here. So the re-equilibration now, right, is going to be 7.5 CVs again. I don't think that was enough, as I recall. I think there was a little blip as you went through to the next cycle, so I'm going to make sure I change this to 10. Change. All right, so that actually makes me wonder, like, let me just check the column equilibration for the desalting column. Okay, 5 CVs. And then as I go to IEX equilibration, all right, so flow rate. Look at this, I didn't set a length of volume that I wanted to re-equilibrate the column for. So like I was just all I was doing was I was just double checking what like my column equilibrations here before I started. And the thing that reminded me of that is like this length of re-equilibration, right? So if I'm on like my 3rd run and I'm trying a new buffer, right? I've got the old buffer in there, say it's a different pH or something. This and like these 2 instructions, this one has to be enough volume to be able to re-equilibrate the desalting column. And this right here has to be enough volume to re-equilibrate the ion exchange column. We know full well that it takes a while to re-equilibrate an ion exchange column, so I'm going to do this for 10 CVs. Change. Okay, and that's going to be same as main. This is main. Okay, so we got that. All right, I think, let me check my notes, but I think that's it for the text instructions. All right, so we've made it this far. I paused the video just to kind of review, so I wasn't wasting any of your time. The first thing I noticed that we hadn't done so far was save the method. So I highly recommend saving the method. I decided to call my file 2DIX, and then we're gonna do scouting now, and all the other run startup functions. So let's hit scouting. Another thing I did was I added 4 extra runs. So if you remember from the intro, we were gonna do all 4 of these like columns twice over, one with pH 8 and one with pH 9. So I didn't think you guys would want to watch me like click through these things and select them, but it's just I did like 4 and then I repeated the same 4 one and again. So these were the variables we ended up with. You know, this is exactly what you would have seen. So the first thing was we have this desalting flow rate, and you notice that the variable name is just called flow rate. Let me show you what I mean by that. It's right here. It just says flow rate. So we're going to change that. And it's in the system flush. It says desalting flow rate for the block name. That's probably why we made the mistake. So we're just going to add desalting to this really fast. Okay. Change. All right. So that makes it easier to read as we look at the variable list. All right, and that closed it. So we're going to do select variable. You know, we don't need to select this variable, honestly, but that's where it would be. And then what I want to show you guys is when I hit OK, it'll come up and it'll say 4 mils a minute. So there, it was 1 before. So what are we going to select here? For the most part, we're just going to select things that are going to change. And the thing we are changing, as I showed you in the intro, was the buffers we're using. So we're not going to change the sample inlet, but I want to keep this variable here because it helps sometimes to see these variables. And the variable you keep is the one that you feel are just like key, they're critical. So, okay. I just wanted to check the volume that we're loading because it used to be 10 mils, right? And we've got this as 2 mils. Okay. So we're going to remove desalting flow rate and we're going to pick the buffers that we're using. So that's Inlet A and Inlet B. And the reason these are desalting and ion exchange buffers is because they're the same buffer. We're using them through the whole run, right? Then we're going to also select the wash for these because if we change the buffer, we need to wash it after we use it, before we use it, I'm sorry. So wash A and wash B. Okay. Then I want to keep, like I said, I want to keep the sample inlet here. And I also want to do the gradient because I could change the gradients as I go along. I could add even more runs. So let's find the gradient. Let me know if you see it. Length of IX elution. I think that's it. Okay. Yep, it's 750. I'm going to make these 10. Okay, it was a little scattered, but I got it. Okay, so we're not going to have A1 and B1 the whole time. So starting at run 5, we are going to do A2. And starting at 5, we're going to do B2. So for the washes, we're going to do A1 and B1 for run 1. And then we don't need to change or wash, sorry, we don't need to wash A1 or B1 in runs 2, 3, or 4, but we do need to wash it in run 5. And we need to wash the same buffer that we're using. And again, we don't have to wash in any of these runs, 6 or 7 or 8. Okay, that's it. That's scouting. Okay. And then now we're going to do the run setup. I think I'm going to keep all of these. I always like the fraction collector, variable list scouting, text instructions, so that way I can type in, you know, some details about what I'm doing. I'm sorry, not text instruction, notes. That's where I would type that in. Text instructions, that was very helpful, and then result name and location. So that's good, and then I want to check result name and location, and I'm going to call it 2DIX. Great. Okay. Thank you very much. I hope you made it to the end of the video here. If you have any comments, please leave them below. I'd love to hear about some of your ideas for tutorial videos I could do. All right, so I'm coming back to tell you if there are any mistakes that need to be fixed, and there are none. The method worked fine. There were some improvements, though, that I was able to make that I felt were worth showing you guys. So the first one was that originally I was planning on using 2 5 mil loops strung end to end to make a single 10 mil loop. Well, for the ion exchange method, the elution volume was about 3 mils on that, so I definitely didn't need a 10 mil loop. I just decided to use one 5 mil loop. That means that I could take this system's flush phase right here and change this 20 mil system wash that includes the injection valve, the injection loop, right? And I can just change this to 10 mils, so that way I'm washing it with 2 loop volumes. And then because I only have a 1 5 mil loop on there, the ion exchange loading, I'm able to cut this off as well. So I don't need 10 mils here anymore. I can do 5. All right. Along that route, I also decided that for the ion exchange equilibration phase, that 10 CVs was way too much. And at the time, I just backed it off to 8 mils. All in all, I would say with these 3 changes, I saved about 10 minutes, and those 10 minutes can really add up. So I am going to make another video that shows you the setup and the results, but I just want to flash the results, one of the result files I got, and this is a good one right here. So this is the desalting going on right here. I'm not really sure what's going on in the pre-phase. Maybe there was some sample in the loop. I'm not exactly sure. But this is desalting. So here's the protein peak and then the salt peak that comes right after it. This is the ion exchange loading, and then this is an elution right after it. Okay, thank you very much.